Hey, Jiang. What about the test results?
Mr. Nan, it's not looking good. We've bought over a dozen top-strength steel cables from overseas, and none of them have passed the fatigue test. Mr. Nan, it seems that the 500 MPa strength requirement is very difficult to meet.
It doesn't matter if the whole cable doesn't work. We'll start with the basics.
Uncle Jiang, what is the basic material?
See if there's a lot of thin steel cables in here? We're gonna break down the cable now. Let's take one of the thin monofilaments first.
So many of them together won't work, but a single one will.
We'll have to try that.
Yeah, well, then it's a deal. Jiang, tomorrow you'll go to Farson from Huayin, Jiangsu province. They'll help with the monofilament experiment.
Yes!
Hey, Jiang. How did it go?
Good news, good news.
Yes, Mr. Nan. The monofilament test reached 550 MPa. It's over the 500 megapascals we said earlier.
Looks like the base material is okay. Let's continue with the whole rope test.
What's taking so long? We've been working on this for over a week.
We have to do 2 million anti-fatigue tests under the stress amplitude of 500 MPa before we can determine the result.
Yes, I am. How did it turn out? 1,100,000 times. No need to wait. The cable broke at 1,100,000 times. Jiang, let's analyze it again.
It's strange that a single wire is fine, but not a whole wire. Shouldn't it be like chopsticks? The more you have, the harder it is to break?
But in this particular case, there should have been friction between the monofilaments.
There's a lot of possibilities.
There's strength in numbers, though. But if there's friction between them, it could affect the power of the whole.
Ha, that's a good one. Next, we'll have to figure out how to fix the friction between the monofilaments.
Is there a cable-making process that separates the wires?
Separates. I've heard good things about this company's coating process. Let's give it a try.
Mr. Nan, we have organized a special research team to work with you.
Thank you.
Where's Uncle Jiang? Why isn't he here?
Zhang Peng is in Beijing. We have to do this trial in several places at once or we won't have time.
For what reason?
Because it takes 2 million times to do the fatigue test of a steel cable. Even if it doesn't stop for a second, it will take 2 weeks.
So long?
One cable isn't enough. You have to make at least 3 cables to evaluate it. Time's running out. Let's get started.
Hey, I don't even want to answer the phone, because when I do, Hey will just tell me it's broken again.
This is not the way to go. Let's go see where the breaks are.
The cable keeps breaking. It's hard.
Lao Tzu once said that softness is better rigidity because rigidity is easy to break while softness is not.
Yes, when we designed fast, we insisted on flexible supports.
I'm thinking that the improvement of the technological path is still focused on the optimization of the flexibility of the cable process.
That's a good point. We're optimizing it.
Mr. Nan is great. He's always coming up with new ideas.
Yes, there's more to Mr. Nan than expertise, more than skill.
The experiment took 2 years, with repeated failures, corrections, and improvements. Finally, Nan Rendong and the team worked together on a joint project. Developed a finished cable for steel-stranded wire. Changed the previous problem of too much rigidity of the wire rope. Improved flexibility, and successfully solved the problem of the rope net.